Again, welcome to Python class. In this lectures, we are going to continue with the selection statement, and we are going to discuss about logical operators. Previously, we talked about the relational operators and how to use them to form a conditional statements. And also we talked about 3 different ways of selection statement in Python. The one-way if, two-way if else, then multi-way. And this lectures now means if I have 2 conditions, for example, if s greater than 8 and y is less than 2, do something. I can combine these 2 conditions as one condition using logical operators. So we have not, and or, 3 logical operators. So our main objective in this lecture is to combine conditions using logical operators. And these logical operators are and, or, and not. Also, we are going to use the logical operators or selection statement with combined conditions. To combine 2 or more conditions, we need logical operators. So we're going to go through a program named leap year, another one named lottery. Then we're also going to understand the rules that govern operator precedency. For example, the not comes before and, then or, like multiplication first, then addition, subtraction. Multiplication, division, addition, subtraction, and parenthesis is first. So let's start with our lectures. So first we start with logical operators. So the purpose of using logical operators in Python is to combine 2 or more conditions. And we have 3 types of logical operators: the not, and or. So not is a logical negation, which means if it's true, not true is false. If it's false, not false is true. So sometimes we refer not operator to as a unary operator because it's only one condition it takes. But and or are called binary or even more than, and we can have more than 2 conditions and to combine 2 or more conditions. So and means logical conjunction. Logical conjunction means if I have a minimum of 2 conditions, both of them have to be true in order to get a true output. Now, if I have 10 conditions, all the 10 have to be true in order to get true output. So if I have 10 conditions and 9 of them are true, but 1 is false, I'll get false output. With or is logical disjunction, which means all we need is only 1 condition have to be true. So if I have 2 conditions and 1 is true, I'll get true output. If both of them are true also, I'll still get true output. Now, if I have 10 conditions and 9 of them are true, I'll still get true output. If 1 is true, I'll still get true output. If all of them are true, I'll still get true output. So the only time I'll get false is if all of them are false. And with n, the only time I'll get false 3 times. And the only time I'll get true is when all of them are true. So this example given for us, we shall go through what is called the truth table for operator. Here we are doing the operator not. Not is, as we said, it's a unary operator, so you can see we have only 1 input. So if it's P is true, not P is false. If P is false, not P is true. So it's like negation, need to negate. Now, if we have a condition here that age is 24, gender is F. Now, when we say not age greater than 18, the answer will be false because age is 24. 24 is greater than 18, that's true. But not true, we have not. So we get false. That's what we say, because age greater than 18 is true, not true is false. The same thing applies to the second example. We know gender is F. So not gender equal to M or male is true because it's supposed to be female. So not female then means not true. Not true is false, not false is true. So the condition is true here. Gender is equal to F. Now gender equal to M is false because gender is equal to F. But not false, it will give us true. So that's why here we say that because grade is M and M is false, not false is true. Now let's go through the truth table for operator N. Here we are using only two possible conditions. So we are assuming P1 is a condition, P2 is a condition, and we combine P1 and P2. So if both condition P1 and P2 are false, we get false. If one of them are false, so if P1 is false and P2 is true, we still get false. Now, if P1 is false and P2 is true, we still get false. So we only get true when all the conditions are true, P1, P2. So we are using the same example here again. If we have a variable age and the value is 24 and the weight is 140. Now, if we said age is greater than 18 and weight is greater than or equal to 140, let's see, is age greater than 18? Yes. But is weight greater than or equal to 140? Is false because weight is greater than 140. Here we're supposed to have only 140. So this means one condition is true, but since one condition is false, the answer is false. Now here we say age is greater than 18. Yes, 24 is greater than 18. Weight is less than or equal to 140. Yes, weight is 140. So this will give me true. So true, the output will be true. Now age is greater than 18 and age is less than or equal to 140 are both true. But here we have age, here we're supposed to have the sign only greater, there's no equal here. Because greater than or equal will give us true because weight is 140. So let's try the truth table for all operator. We are using two conditions again, P1 and P2, but now we can see here, we only get false when both P1 and P2 is false. We assume P1 is one condition, P2 is a second condition. Now, if one of them is true, that's it. So all of them are true. And if both of them are true, also is true. So here, let's see. We have age is 24, weight is 140. Age greater than 34, that is false. Age greater than or equal to 1, that's also false. So since both are false, our output will be false. Now, second one is age greater than 14. I will stop because that is true. So if the first condition is true, the second condition doesn't matter. It can be true or false. We still get true output. So let's see example how this Boolean. First of all, let's go through this example. Here they say we have a program that will check whether a number is divisible by 2 and also by 3. Also whether the number is divisible by 2 or 3, and whether the number is divisible by 2 or 3, but not both. So first we are checking if the number is divisible by 2 and 3, which means we use the AND operator. Is divisible by 2 or 3, then we use the OR operator. And whether the number is divisible by 2 or 3, but not both. So let's see this program first. So here first we ask the user to enter the number. So we receive our input and we convert the input to an int. Now first we checking our condition here, but remember the question said we should check if 2 and 3 is divisible by the number. So we have two conditions. First, number modulus 2, we are checking if the number is divisible by 2. The remainder should be 0 then. And the second condition, number modulus 3, we are checking if the number is divisible by 3. So remainder will be 0. So here, our main thing we are learning is the AND logical operator. And this means both have to be true. So if both of them are true here, then we print this. The number is divisible by 2 and 3. Now the second option, we are using the OR operator. So this means only one of the conditions have to be true. So we are checking if the number is divisible by 2. That's why we have modulus 2. And also we are checking if it's divisible by 3. So modulus 3. So here is divisible by 2 or 3. Only one condition have to be true. Or here we can say it's 1 and 2. So we say if the number modulus 2 equal to 0, or the number modulus 3 equal to 3, and not, you see here what we say that the number can be divisible by 2 or 3, but not both. Here is for both. Number modulus 2 equal to 0 or number modulus 3 equal to 0. So this means the number should be divisible by 2 or divisible by 3 or both 2 and 3. So here we are using the negation, not modulus 2 and modulus 3. So here we are making sure the number is not divisible by 2 and 3 at the same time. So you can see we use the n to have both number modulus 2 equal to 0 and number modulus 3 equal to 0. Both should be true. So if both is true, we convert it to not false. Then here we print the number that we enter is divisible by 2 or 3, but not both. So this printout is for the third condition here. This printout for the second, and this printout for the first. So now we have another program here. We're going to use the logical operators again. We want to determine a leap year. We know a leap year always happen every 4 years. So this program first prompts the user to enter a year as an int value. Then we're going to check if that year is a leap year. A leap year is a year that the whole year is 366. The regular years are again 365. So we say here a year is a leap year if it is divisible by 4, because this happens every 4 years, but not by 100, or it is divisible by 400. So we can see our condition here. We say the year should be modulus 4 equal to 0, which is good every 4 years, but also not 100. So year modulus 100 not equal to 0. So this condition means it's a leap year. Or y modulus 400 equal to 0. That's also a leap year. So what we do here, we are using the logical operators again. So let's see this program also. So we ask the user to enter the year. We convert the year to int. Then we are checking our condition here now. What the year we enter modulus 4 equal to 0, and the year we enter modulus 100 not equal to 0 is a leap year. Or there's another condition, or the year modulus 400 equal to 0. So what we are learning here again is how to use the logical operators. Here we are using the AND, and we're also using the OR. The previous code, we were able to use almost all of them, not AND and OR. So if this condition is true, then we're going to display that the year we enter is again leap year. Now, if this condition is false, then we're not going to print. So we have another program for lottery. Here we're going to write a program that randomly generates a lottery number between 0 to 99. It will prompt the user to enter a number in the same range and determine whether the user wins according to the following rule. So if the user matches the input in exact order, the award is 10,000. If the user input matches the lottery, the award is 3,000. And if one digit in the user input matches a digit in the lottery, then only one digit, you get $1,000. So we have 3 different conditions. You get 10,000 when the user input matches the whole lottery in exact order. But you get 3,000 when it matches it, but not in exact order. And if one digit is correct, then you get $1,000. So let's see this program. First, we want to generate the lottery number. We said the lottery number is from 0 to 99, so we have the round int 0 to 99. Then now we prompt the user to enter a guess, and the number we generate, we want to see if it can match the number. So we ask the user, enter your lottery pick, 2 digits, and convert it to int and store it in a guess variable. Now get digit from lottery. So we want to get a digit. We have 2 digits. So lottery divided by 10. This is an integer division. We don't want to take the decimal value. So for example, 25 divided by 20, I want to get the answer to be 2. Then when I use the modulus operator, I'll take the last digit, 5. And that's what we did here. We divide integer division by 10. We assign the result to lottery digit 1. Then the lottery modulus 10, that will be the remainder after we divide by 10. And that will be our seconds. So the reason why we divide by 10, you can see that if I enter 32, if I divide by 10, I'll get 3. When I make it modulus 10, I'll get 2. So you want to get the 3 digits, the 2 digits that you enter, you want to extract them. So what we're doing, we're getting the separate 2 digits. Then here, say we get a digit from the guess. This is the digit that we know is correct. We enter, for example, I enter 72. This will be 7 and 2. Then I'll go to the second, guess 1. So we say guess divided by 10, and also we want to get a 2 digit there. After we get the 2 guess digit that randomly was generated, we're going to print that. So we say the lottery number is lottery, but we have to start with a guess. We want to check if the lottery result and the guess, they are equal. If they are the same, then we say we win 10,000. Otherwise, we see if the digit, what we mean by the same, if 72 and I get 72, I get 10,000. But if 72 and I get 27, then I get 3,000. The same 2 digits, but they are not in order. So that's why the second option, we are trying to get the digits, 1 digit at a time separately. So we assign lottery digit 1 to guess digit 2, and then lottery digit 2 to guess the digit 1. So we check the pass. Then we print if they match. If they match, we get 3,000. Otherwise, we say guess digit 1 equal to lottery digit 1, or guess digit 1 equal to lottery digit 2, or guess digit 2 equal to lottery digit 1, or this. Then here we print match 1 digit, you win 1,000. If any of digit match, you win 1,000. If not, and you didn't win any exact number, then we say print, sorry, no match at all. So again, the goal of this program is learning again how to use the logical operators, and also we are using the multi-way selection statement. The logical operator we are using here is or. You can see here we have 1 condition, or this condition, or this condition. So here we have 1, 2, 3, 4 different conditions, but only one of them have to be true because it's or. So if one of them is true, then the winner win 1,000. So we also have what we call the conditional expressions. So for example, here we say if s is greater than 0, assign 1 to y. Otherwise, assign -1 to y. This is equivalent to writing that y equal to -1 if s is greater than 0. I mean, y equal to 1 if s is greater than 0. See, if s is greater than 0, y is 1. S is -1. So y is 1 if s is greater than 0. Else, is -1. So this is example. If number modulus 2 equal to 0, we say we are printing an even number. As we print that the number is odd, because here we have only 2 options. A number can be even number or odd number. And this are the operator precedence. We start with, again, addition, subtraction, exponent, not multiplication, division. We have 2 division. One is regular division. Second is integer division. The modulus operator. We saw the relational operator. So relational operators come before the n, or, and also the not operator is number 1, it's way up. So operator precedence and associativity. We say the expression in the parenthesis is equivalent first, then parentheses can be nested, in which case the expression in the inner parenthesis is executed first. This is the same concept as a college algebra or arithmetic. If I have a value in the parenthesis, let's say 2 plus 1 in the parenthesis, and I have another outer parenthesis 4, close everything, it means I'm going to add the 2 together, deal with the inner parenthesis first before the outer parenthesis. And we also said if the operators with the same precedence are next to each other, then the associative determine the order of evaluation. And most of the time we say from left to the right we're going to use. So this is an example. A minus B plus C minus D is equivalent to A minus B plus C, then minus D. The reason why this is equivalent because plus and minus, they are in the same precedence. So this will be our conclusion of our lectures on logical operators in Python. So again, as we said, in Python, we have 3 types of logical operators: the not, or, and n. And the purpose of using logical operators is to combine 2 or more selection statements or conditions. So again, wish everybody the best, and thank you for your time.